question 1. So to factorise fully, we've got to put the brackets in, and because it says fully, that's reminding us that we're going to be taking at least 2 things outside the bracket. So what's the highest common factor of 4 and 6? Well, that's 2. And then can we take a p out from each term? Yes, we can. So 2p. Can we take out any q's? No, we can't, because we don't have a q common to both terms. So we've taken 2p outside the bracket. Then 2p times what gives us 4p? Well, that's 2, because 2p times 2 is 4p. Get the sign right? Well, it's a plus, so pop a plus in. Then 2p times what gives us 6pq. Well, we need the 3 to get the 6. We've got a p already, but we need a q, because 2p times 3q is 6pq. Part B. So expand and simplify this pair of brackets. Well, expand means getting rid of the brackets, and simplifying means gathering your like terms at the end. So for step 1, let's expand the brackets. So we have the 4 clause, a clause from the e to the e and the e to the minus 5, and from the 3 to the e and the 3 to the minus 5. Remember, with each of these clauses you multiply. So e times e is e squared, e times minus 5 is minus 5e. Moving on to the plus 3. 3 times e is plus 3e, and plus 3 times minus 5 is minus 15. So we have now expanded. We've got rid of the brackets, and we now need to simplify, so we have to gather up our like terms, so the terms which are similar. So we have a minus 5e and a 3e here. 3e minus 5e is minus 2e. So our final answer is e squared minus 2e minus 15. Part C. So to undo this dividing by 5, we start off by multiplying both sides by 5. So 5y equals the numerator 2y plus 1. Now we've got to take away 2y from both sides. So taking away 2y from both sides, we get 3y equals 1. Then finally, to get y on its own, 3y means 3 times y. So to undo timesing by 3, we divide by 3. So y equals 1 divided by 3, which is a third. 2 part A. Describe fully the single transformation that maps triangle A onto triangle B. Now I think we can see it's a rotation by 90 degrees. We can see it sort of flipping around. And I think really you've just got to trial and error using tracing paper to see where the centre of rotation would be. So you eventually get to there, hopefully, minus 2, 3. And then you can see if you've got tracing paper over both the shapes, you put your pencil there to form a pivot, draw around the A, and you'll see that if you rotate it 90 degrees clockwise, your shape will transform to here, B. So to describe it, we've got 3 marks. 1 mark for saying rotation, 1 mark for saying 90 degrees clockwise, and the 3rd mark for saying about the point minus 2, 3. Part B. Now translate means to shift. So we've got to shift the shape A by the vector 2 minus 5. So this vector pretty much works the same way as a coordinate. So think of this as being 2 to the right and 5 down. So we've got to shift this shape A 2 to the right and 5 down. So take a point of your choice, for example bottom left, and just make sure you shift that bottom left point 2 to the right and 1, 2, 3, 4, 5 down. So that point shifts to there. So filling the shape in above, that's where we shift to, translate to, translating A to triangle C. Part C. On the grid, enlarge triangle D with scale factor 1/2 and centre minus 4, 2. So they give us this centre. Now because the scale factor is 1/2, it's going to be half as far away from this point and also half the size. So it's going to be half the size of this and half as far away from here. So let's take for example this point here, which is presently 1, 2, 3, 4 along and 2 up. So if we halve that, we go 2 along and 1 up. So that point maps from there to there. Now at that point, because we know it's top left hand corner, we could just fill the shape in because we know it's going to be half the size. So rather than 2 along, it's going to be 1 along, and rather than 4 down, it's going to be 2 down. So we don't need to do any further work, we could just fill the shape in. But if you want to double check, you can do all the points if you want. So this blue point here is 1, 2, 3, 4, 5, 6 along, 2 up. Half that we need to go 3 along and 1 up. This bottom point here, that's 4 along and 2 down. Half that we go 2 along and 1 down. Question 3. So we're told that the spinner response, once probably the spinner lands on brown, is 0.06 more than the probability that the spinner lands on yellow. So if we make yellow the smaller one, so make that x, then we know the chances of it landing on brown is x plus 0.06. So we know all the probabilities have to add up to 1, so we can now construct an equation which we can then solve. So 0.15 plus 0.26 plus 0.33 plus x plus 0.06 plus x has got to equal a whole. So simplifying the left hand side, we get 2x plus 0.8 equals 1. Take away 0.8 from both sides, divide by 2, we can see that the probability of x equals 0.1. So the probability of the yellow is 0.1. Now, Jenny spins the spinner 150 times. Estimate the number of times the spinner will land on yellow. Well, if we spin it once, the chances of it landing on yellow is 0.1. So if we spin it 150 times, the number of yellows we would expect to get is 150 multiplied by 0.1, which is 15 times. Question 4, part A. So to work out the percentage increase, we have to divide the increase by the original amount and multiply it by 100%. So the increase is obviously going from this to this. So this, take away this, gives us 110. We then divide this 110 increase by the original amount, the 1126.50, multiply this by 100, we get 9.764 ... So to 3 significant figures, that means 3 digits in total, but being careful with the rounding, we get 9.76%. Now for part B, to increase by 19%, our multiplier is 1.19. So we take our price at the 1st of February 2016, 1126.50, multiply this by 1.19, and we get 1340.535. So to the nearest dollar, rounding up, we get $1341. Question 5. Now we've got to show that BCD, this straight line here, is parallel to AFE. So let's start off by working out what x is. So we know that angles on a straight line add up to 180 degrees. So we know that this angle here plus this angle here must add up to 180. So we can construct and solve a linear equation. So 4x plus 15 plus 30x minus 5 equals 180, because angles on a straight line total 180. Now we can just solve this, so let's simplify the left hand side. So 34x plus 10 equals 180. Take away 10 from both sides, divide by 34, we can see that x equals 5. Now if these lines are parallel, then this angle here, angle FCD, is the same as this angle here, AFC, because alternate angles are equal. That's the x angle rule. Well, we've just worked out that x is 5, so let's pop 5 into here to work out this angle, and pop 5 into here to work out this angle, and if we get the same answer, the angles are the same, so the two lines must be parallel. So popping the 5 into here, we get angle DCF being 30 lots of 5 minus 5, which is 145 degrees. Popping our 5 into here, we get angle AFC also being 145 degrees. They're both the same, therefore parallel lines as alternate angles are equal. Question 6, part A. Well, we can see that the shape of this is going to be a positive parabola, a smiley face, because it's a quadratic and we've got a positive x squared. So we can therefore look out for the symmetry amongst the y values. So we think of it as being a ripple, a wave going from the naught to the naught. So this 2's got to line up with this 2, and this 6 has got to line up with this 6. Now we could of course have just worked out these y values by substituting the x values into the formula, but looking for the symmetry is a bit quicker. So I've now gone for part B, gone and plotted these points. So 0, 6, 1, 2, 2, 0, and so on. Now for part C, by drawing a suitable straight line on the grid, find estimates for the solutions of this equation here. So this, I've got to think about this a little bit. So this is our starting point. Now our curve, our quadratic, is x squared minus 5x plus 6. So I really want this left hand side to equal my curve, so I'm going to choose to add 6 to both sides, which is obviously keeping it equal. So my left hand side is now x squared minus 5x plus 6, which is my curve. So I want to find out where this curve intercepts this line here, where they are equal. So I now need to just draw the line y equals x minus 1. So whatever my x coordinate is, my y coordinate is one less. So for example, point 0 minus 1, 1, 0, 2, 1. So I've drawn in my straight line here in red, y equals x minus 1. I've read off where they intercept, and that's at 1.6 and 4.4. Question 7, part A. So, as this is a positive power, we're going to be getting a big number. So, as a working, write down 7.18 and pop down lots of zeros to the right, giving us something to hop over. So, the number is going to be 7 times bigger. So, think of it as the decimal point hopping 7 times. Obviously it's the numbers that are moving and decimal points staying still, but I think for this purpose it's easier just to think with as the decimal point hopping. So it hops 7 places, 1, 2, 3, 4, 5, 6, 7. It finishes here, so we need to have 5 zeros after the 8. So 1, 2, 3, 4, 5, that's our final answer. For part B, calculate the total volume of these 4 oceans. So I simply just added these up on my calculator using the times 10 to the bottom middle, and I get this answer in standard form, or alternatively you can give this as the normal number. It doesn't specify how to give your number. Now for part C, we've got to write this big number in standard form, so write it down as a working. Now for standard form, the first number's got to be between 1 and 10. So the decimal point is going to have to be between the 9 and the 8, giving us 9.88. Then times 10 to the something positive, because it's a big number. The decimal point is effectively on the end to start with. It needs to move to be between the 9 and the 8. So that's 1, 2, 3, 4, 5, 6 hops. So 9.88 times 10 to the 6. Question 8. So, we're told that the area of this isosceles triangle is 12. Well, how do we work out an area of a triangle? It's half times base times perpendicular height, which I'm calling h. So half times 5 times h equals 12. So h equals 4.8. So I've just done a little sketch of half of the triangle to help me gather my thoughts. The perpendicular height is 4.8. This length here is half of 5, which is 2.5, and I want to work out the length x. Now this is a right angled triangle, so I can use Pythagoras. So x squared equals 4.8 squared plus 2.5 squared. So x equals 5.412 dot dot dot. So the perimeter, the length all the way around the outside, is 5.412 plus 5.412 plus 5, which is 15.824 dot dot dot, which to 3 significant figures is 15.8 centimeters. Question 9. So part A, complete the cumulative frequency table. So this is the running totals. This is the speed of 60 bikes. So 3 bikes have got a speed between 0 and 10. 16 have got speeds of between 10 and 20, and so on. So cumulative frequency is the running totals. So how many have speeds between 0 and 10? Well, that's obviously the 3. What about between 0 and 20? So that's all the ones between 0 and 10 and all the ones between 10 and 20. So that's 3 add 16 equaling the 19, and so on. So this is a running total. So speeds between 0 and 30 is this, add this, which is 43. Then the next one between 0 and 40 is the top 4 added together, and so on. So this gives us our cumulative frequencies. Now part B, on the grid draw a cumulative frequency table graph for your table. Now just be careful, when you plot these coordinates, make sure you use the upper bound for speed. So you're plotting the coordinates 10, 3, and 20, 19, and 30, 43. Now no bikes have got a speed less than 0, so really you should just finish off the tail here and go back to the origin. Now for part C, use your graph to find an estimate for the interquartile range of the speed. So the interquartile range is the speed of the bike which is a quarter of the way up, subtracted from the bike which is 3/4 of the way up. Now we've got 60 bikes here. Quarter of 60 is 15, so we want the 15th bike for the lower bound. And 3/4 of 60 is 45, so we want 45, the 45th bike for our upper bound. So taking a reading for 45, we get a speed of 32. Taking a reading for our 15th bike, we get a speed of 19. 32 take away 19 gives me 13. And the mark scheme allowed any answers between 13 to 15. Question 10. Now we've got 2 right-angled triangles here, ACD and also ABD. So we can answer this question just using SOHCAHTOA. So let's start off by looking at triangle ACD, and we can work out the length from C to D, which I'm going to call X. So tan 20 equals opposite over adjacent, so that's X over 13. Multiply both sides by 13, X equals 13 times tan 20, which is 4.73 ... So moving on now to the bigger right angled triangle ABD. My base AD is 13, but I can now work out the length from B to D because it's this 8 from B to C plus this little length I've just worked out of 4.73. So the length from B to D is 12.73. So I can now work out the angle BAD, this big angle here, which I'm calling Y. So tan Y equals opposite over adjacent, 12.73 over 13. Inverse tan both sides, we get Y equaling inverse tan 12.73 over 15. And on my calculator that gives me 44.402. Now I just want this angle from B to A to C. So that's the total angle from B to A to D of 44.402, less this 20, which is 24.402, which rounds to 24.4 to 1 decimal place. Question 11. Well, in order to subtract fractions, we need a common denominator. So both 3 and 2x would go into 6x. So we're going to choose to multiply the first term top and bottom by 2x and the second term top and bottom by 3. That's going to give us the common denominator of 6x. So popping them both over 6x, 5 times 2x is 10x, and then we're taking away 3 lots of x plus 3 lots of 2, so we're taking away 3x plus 6. Now be careful of this claw here. We're minusing 3x and we're minusing 6. So it's 10x minus 3x minus 6 all over 6x. And simplifying the numerator, 10x take away 3x is 7x. So our final answer is 7x minus 6 all over 6x. 12 part A. So to find dy dx, each term we've got to multiply by the present power. So 3 lots of a third is 1, and reduce the power by 1, so that's x squared. And then when we differentiate minus 9x, we get minus 9. Now we've got to find the range of values in B of x for which C has a negative gradient. So it has a negative gradient when x squared minus 9 is less than 0. When the differential is less than 0, the gradient is negative, because remember the differential gives us the gradient. So adding 9 to both sides, we get x squared being less than 9. So our two values for x at the extremes are plus 3 and minus 3. Now just do a quick sketch to help you gather your thoughts of this positive quadratic. We want it to be less than 0, so below the x-axis, so that's when x is less than plus 3 and also greater than minus 3. 13 part A. So always start off with the bits in the middle. So we've got 15 students studying geography, history and RS. So that can go straight into the middle. Now secondly, we're told that 21 study geography and history. So geography and history is all of this bit here. Now we've already got 15 studying geography and history plus RS. So this bit here must be the rest to get up to 21. So that's 6. 21 minus 15 equals 6. So just check you're okay with that. So 21 studying geography and history. Geography and history is the overlap here. So we've got 21 there. Now 16 study geography and RS. So geography and RS is geography and RS. So we need to have 16 studying geography and RS. So this bit here has got to total 16. We've got 15 here already. So 16 minus 15 equals 1. Now 30 study geography in total. So the whole of the geography football has got to equal 30. Well, we've already got the 6, the 15 and the 1. Take that away from 30, it leaves us with 8 studying just geography. Now then 18 study only RS, so that can go straight into that bit there. And then we're told that 37 study RS in total. So the whole of the RS football's got to equal 37. We've already filled in these 3 bits here of 15, 1 and 18. So this bit here has got to be the balance. So 37, take away 1, 15 and 18, giving us 3. Now for part B, we're told a student in year 11 who studies both history and RS. Now how many study history and RS? Well, it's these 18 here. So we're choosing out of 18. We've got to work out that this student does not study geography. So that's these 3. So it's 3 out of these 18. So 3 over 18. Question 14 part A. Now we're told that T is directly proportional to the cube of R. So our provisional formula is T equals K times R cubed. Directly proportional, so it's K multiplied by R cubed. Now we're then told a couple of values allowing us to work out what K is. So when T is 21.76, R is 4. So substituting 4 in here. So dividing both sides by 4 cubed, we can see that K equals 21.76 over 4 cubed, which is 0.34. So we now know that K, our constant, is 0.34. So we can rewrite this provisional formula as T equals K, 0.34, times R cubed. So T equals 0.34 R cubed. Now for part B, work out the value of T when R is 6. Well, that's easy enough. We just substitute 6 into this. So following big mass, it's going to be 6 cubed multiplied by 0.34, giving us 73.44. So we're told that the total surface area of a solid hemisphere, so a solid hemisphere, now a hemisphere is half a football, so the total surface area of a solid hemisphere is equal to the curved surface area of a cylinder. So let's just get a couple of sketches to help us gather our thoughts. Now we're told the radius of the hemisphere is r. So total surface area of half this football includes the circle on the top, which is pi r squared, and then the curved surface area. Now the curved surface area of a whole football is 4 pi r squared from the formulas at the front. So half a football, the curved surface area is going to be half of this, 2 pi r squared. So our total surface area is going to be the circle at the top, the flat circle at the top, plus the curved surface area, which is 3 pi r squared. Now for our cylinder, we're just interested in the, we're told the radius of the cylinder is twice the radius of the hemisphere. So the radius of the cylinder is going to be 2 lots of r, which is 2r. So our diameter, the diameter all the way across, is going to be 2 lots of 2r, which is 4r. Now we're just interested in the curved surface area of a cylinder, so just the curved bit. So imagine flattening out a cylinder into a rectangle. The 2 sides of that rectangle are going to be h, but then the perimeter of the circle is going to be the other side of the rectangle. So perimeter is pi times the diameter, so that's going to be pi times 4r. So the curved surface area of the cylinder is 4 pi r h. Now these are equal to each other. So we can then cancel out a bit. We can cancel one of the pi's, one of the radiuses, giving us 3r equals 4h. Now we've been asked to work out the volume ratio, given that the volume of the hemisphere to the volume of the cylinder. Well, we can do this now. Let's go back to the volume of our hemisphere. Now the volume of a whole football is 4/3 pi r cubed, so the volume of half a football is going to be 2/3 pi r cubed. Now the volume of a cylinder is pi r squared times h, the radius being 2r, so that's pi 2r all squared times h. 2r all squared is 2r times 2r, which is 4r squared, so that gives us 4 pi r squared h. Now again, we can do quite a bit of cancelling out here. We can cancel one of the pi's, well the pi, and r squared, leaving us with 2/3 r equals 4h. But we know that 4h equals 3r. So substituting in, just replacing the 4h with the 3r, we can say that 2/3 r equals 3r. The r's cancel, so we've got 2/3 equating to 3. Now we want it to be 1 to something, so let's go and multiply both sides by 3/2, and that will give us the ratio of 1 to 9/2, which is the same thing as 1 to 4.5. Pretty tricky that, I'd say. 16 part A. Now to rationalise the denominator, you choose to multiply top and bottom by the denominator, but with a change of sign. So we're going to multiply top and bottom by a plus square root of 4b. So just doing the claw, top and bottom, we're going to go a squared plus a root 4b plus another a root 4b, and then root 4b times root 4b, which is 4b. And on the denominator, a squared plus a root 4b minus a root 4b, and then minus 4b. Now these two middle terms then cancel out. So simplifying the numerator and the denominator, we get to this. And that's as good as I can get. I can't improve it any more than that. So that's my final answer for part 16A. Part B. So the square root of y over x is the same thing as the square root of y divided by the square root of x. So that's y to the half divided by x to the half. Now when we have a power inside and outside the bracket, you multiply these together. So this is y to the minus 5 over 2 over x to the minus 5 over 2. Now what I've then done, when you change the sign of the index, it flips it over. So this can be thought of as being, if you flip over the numerator and the denominator, as being x to the power of 5 over 2 all over y to the power of 5 over 2. So the change of sign for the power. So then comparing this left hand side with this right hand side, we can say that m equals 5 over 2. Final answer. Question 17. So we have a non-right angled triangle and we're trying to work out an angle of it. So let's have a think about this. We can't use the sine rule because you need to have a pair. So what we can do here is use the cosine rule. As we've got side, trapped angle, side, we can use the cosine rule to work out the length of AC. So working out the length of AC, I'm going to say that a squared equals b squared plus c squared minus 2bc cos a. That's straight out of the tables. And then I'm just relabeling my diagram to tie in with the given formula. So our angle is uppercase A is 110. So this side here is the lowercase a. Then I'm just switching over my A's and my B's. So substituting in, I can work out that the length from A to C, this lowercase a, equals this. And that gives me A being 7.3707 ... So now that I know this length here, I can use the sine rule. I can say that sin this over this equals sin this over this. So sin x over 5.3 equals sin 110 over 7.3707. Multiplying both sides by 5.3, I can work out that sin x equals this. Inverse sin both sides, I get x being 40.107 degrees, which is 40.1 degrees to 3 sig figs. Just back to when I used the sine rule, do remember that if your unknown is the angle, it was easier just to flip the formula over. So I've used sin A over A equals sin B over B. It just means there's less rearranging to do to make sin x the subject. Question 18, part A. So the change here is inside the bracket, so that affects the x values, but the opposite to what you'd expect. So rather than halving the x values, it's going to double the x values. So the coordinate 3, 0, for example, double the x value becomes 6, 0. The point minus 1, 0 becomes minus 2, 0. 0 minus 3 remains at 0 minus 3. And for example, the point 1 minus 4, double the x coordinate, becomes 2 minus 4. So it's a stretch in the direction of the x-axis. Now for part B, write down the value of k. So we've got x plus k. So it's inside the function again. It's inside the function again. So it affects the x value and does opposite to what you'd expect. So let's take, for example, the point minus 1, 0. That minus 1, 0 has become minus 4, 0. That minus 1, 0 there has become minus 4, 0. So the graph is transformed 3 to the left. So your temptation would be to say x minus 3. But as I said earlier on, if it's inside the function affecting the x value, it does the opposite to what you'd expect. So that's not x minus 3, it's x plus 3. So k equals 3. Question 19, part A. So write down the range of the inverse function of g. Now this is the g function, and we're told that the domain, so really the home, is for all values where x is greater than or equal to minus 3. So we substitute in, you would substitute in all values of x greater than or equal to minus 3 into this in order to get the range of values for the function. So the domain is the starting point, the x values, and the range is the y values. Now we're being asked to write down the range of the inverse function of g. Now you've just really got to learn that the range of the inverse function is the same as the domain of the function itself. So the answer to part A is going to be that the range is greater than or equal to -3. Now it's a range, so we're talking about the y values, so the y values are going to be greater than or equal to -3. Now part B, express the inverse function of g in this format. Now you would have practiced that to do this we need to change the subject. So we really take our function, we set y equaling to the function, and we follow the algebraic process to end up with x equaling whatever. Now the problem we have here is that x is appearing twice. So in order to be able to change the subject, you had to appreciate that you needed to complete the square to start with. So x squared plus 6x is the same thing as x plus 3 all squared minus 9. Now just in case you don't know how to complete the square, the starting point is to just halve the value which is the coefficient of the x. So we're halving the 6 to get plus 3. So our starting point is x plus 3 all squared. Now when you do x plus 3 times x plus 3, you get x squared plus 3x plus 3x plus 9, or in other words x squared plus 6x plus 9. But we don't want the plus 9, so we have to back this out with minus 9. So this line here is the same as this line here. And now that x is only appearing the once, it's quite straightforward to change the subject to make x the subject. So we undo the minus 9, we add 9 to both sides. Then to undo the squaring, we square root both sides, giving us plus or minus the square root of y plus 9, equaling x plus 3. We then take away 3 from both sides to give us x equaling minus 3 plus or minus the square root of y plus 9. Now we know that the domain is x has got to be greater than or equal to minus 3, so it's going to have to be just the plus version, so just minus 3 plus the square root of y plus 9. And then remember, y is just something we've artificially introduced to allow us to work out the inverse function, so our final answer is minus 3 plus the square root of x plus 9. Question 20. Now I think this isn't ever so difficult, so bear with me here. So we're told that a bowl contains n pieces of fruit, of which 4 are oranges and the rest are apples. So we've got 4 oranges, a total of pieces of fruit being n, so the number of apples must be n minus 4, because 4 plus n minus 4 equals our n. So that's the first thing to take on board, that we're starting off with n minus 4 apples. Now 2 pieces of fruit are taken, and we're then told there are n minus 6 apples. So that must mean for us to have ended up with n minus 6 apples after taking 2 pieces of fruit, that both those pieces of fruit that were taken must have been apples for us to go from a starting position of n minus 4 apples to n minus 6 apples. So we're saying the probability of an apple followed by another apple equals a third. So that's the key bit. Right, now okay, well, as we take our first pick, what's the probability of selecting an apple? Well, it's n minus 4 out of n. So n minus 4 out of n. Now, we're then going to say, what about if we then take an apple as our second pick as well? So probably of an apple and an apple. So there's the probability of the first apple, and so multiply the probability of then getting an apple with our second pick. Well, how many apples have we got as we take our second pick? We've got n minus 5 apples. And how many are we choosing from? We're choosing from n minus 1 apples. So probability of an apple and then another apple equals a third. So we've just constructed an equation that we can solve. So let's choose to go and multiply by n minus 1 each of these terms. So we end up with no, let me say that again. So let's choose to undo the denominator by multiplying both sides by n times n minus 1. So we're multiplying both sides by n times n minus 1. On the left hand side this just leaves us with the numerator, and on the right hand side we've got a third of n times n minus 1. So if we multiply out the pair of brackets we get this on the left hand side, and multiply this out we get this on the right hand side. Now at that point I've gone and just simplified my left hand side. And then what I'm going to do now, because I've got the thirds on the right hand side, I'm going to choose to multiply through by 3, which gives me this. Taking everything to the left hand side I get this quadratic equation, and now because everything is even I can just divide through by 2, giving me this more straightforward quadratic equation with just a single n squared. So factorising this I get n minus 10 n minus 3 equaling 0. So I've got two theoretical values of n being 10 or 3. Well, clearly n can't be 3. We can't have a total number of pieces of fruit of 3 given we've got 4 oranges. So n must therefore equal 10. Question 21. Now we're told these are 3 consecutive terms in an arithmetic sequence. Now remember what an arithmetic sequence is. That's when you add the same number on each time to get the next number. So the difference between these two terms and the difference between these two terms are the same. So therefore this take away this must equal this take away this. And that is really how we construct our opening linear equation. We're saying this take away this equals this take away this. So that is our opening line. And then just be careful, we're taking away the 2x and taking away the 23. So that on the left hand side gives us 6x taking away 21. And over here on the right hand side again we're taking away 8x and we're taking away 2, giving us 12x minus 54. So if we then take away 6x from both sides and add 54 to both sides, we get 33 equaling 6x. Divide through by 6, we get x equaling 5.5. So if we then just substitute 5.5 back in to these 3 terms here, we get 34, 46 and 58, and we can then see that the common difference is 12.